Good afternoon, students. My name is Mr. Chimanda. Welcome back to our grade 12 maths lockdown school. Um, this week we have been doing our trigonometry at grade 12, and we've been from Monday we've been doing the compound angles of trigonometry. So now we are going to go further and see how do we integrate from compound angles to double angles. Right. So we did some solving yesterday of some questions. We solved trig equations using the double angle, where we had to expand or use an identity to create an equation that we were able to solve. But today we learn about double angles. So I'm just going to quickly stop sharing the screen, and we're going to do them today. So the question that comes into play is, what are double angles and how do they come by? So double angles, they come from compound angles themselves. So I am going to write down and derive all the double angles that we know. So the compound angles that we know, the compound angles that we know are, we're going to start with sine. We're going to start with what? With sine. So when we start with sine, right, right. When you start with sine, it becomes sine A plus B, right? We say this is equals to sine A sine A cos B plus cos A sine B. That is for two different angles. If the two angles are different, then it's totally different, right? Now, but if I am going, so this is a compound angle. So the double angle for this one will be, so the double angle is derived from the compound angle. So double angle becomes sine A plus A is equal to sine A cos A plus cos cos A sine A, because we have A and A here. But A and A are the same. So that's where the name double comes from. This one is compound because they're different. This one is double because they're the same. So this one now, I can easily write it as, well, sine A cos A and cos A sine A are the same. It's just like saying A, B, and B, A, right? This is the same variable because it's just which one has been placed before the other. So now I can, so this and this, if they're the same, I can write them as 2 sine A cos A. So sine 2A, so this is the identity for the double angle. Sine 2A is equal to 2 sine A cos A. It's very important. So you can actually see that we have derived it from the what? We have derived it from the double angle, from the compound angle. So this is the double angle. I'm just going to quickly place it for sine. Let's go to cos. What is the identity, or how do we derive? So let's go cos A plus B is equal to cos A cos B minus, remember the identity. If you are not sure, you have to look at it. Then we have sine A sine B. But now, when I am when I now go to the double angle, it becomes cos A plus A, which is equal to cos A minus sine A sine A. Now we go further, this becomes cos squared A minus sine squared A. And A plus A is cos 2A. That is one of the first double angles. So the double angle for cos 2A is cos 2A is equal to cos squared A minus sine squared A. And here we have sine 2A is equal to 2 sine A cos A. Let's go to the other. So we can see that we have cos squared A minus sine squared A. But remember, we also have an identity, right? We also have an identity that says cos squared A plus sine squared A is equal to 1. This is another identity. So it means if I make cos A the subject of the formula, so cos squared A is equal to 1 minus sine squared A. If I make cos A squared A the subject of the formula, I can come now and substitute in here. If I substitute in there, it becomes cos 2A is equal to, so because cos 2A, cos squared A is equal to 1 minus sine squared. So it will be 1 minus sine squared A minus sine squared A. This where is this one? And this is just what I've written. So this becomes cos 2A. This becomes cos 2A is equal to 1 minus 2 sine squared A. We have found another formula, another identity. So now it depends on your scenario. Which one do you want to use? Do you want to use this one? Do you want to use this one? It depends on what scenario you would want to, but both identities work. So this is identity number 2, identity number 3, right? Oh, in this case, remember we made cos squared A the subject of the formula. So in 10, we can make sine squared A the subject of. So if we make sine squared A the subject of the formula, it becomes 1 minus cos squared A. So now I can come and substitute it. I'm going to draw a line like this. I can come and substitute it in here. If I substitute it in there, then I can now have cos 2A is equal to cos squared A minus, where there is sine squared A, I'm going to substitute with 1 minus cos, minus 1 minus cos squared A. So if you look at it, where the sine squared, not the negative, I left it outside. I took 1 minus cos squared A and I substituted it and put where there was sine squared, 1 minus cos squared. Because if you don't do that, then you omit this one and it will not come out right. So this becomes cos 2A is equal to cos squared A minus 1 plus cos squared A, because this negative and this negative will give me a positive, right? So this becomes cos 2A is equal to this plus this gives us 2 cos squared A minus 1, which is identity number 3. Identity number 3, number 4. So you can actually see that under cos we have 3 different identities under cos 2A. So you will decide which one you want to use depending on the scenario, on the questions that you are given. You shall see later on when you are solving the questions that which one should we implement. I will always be bringing back this page. All right. Let's go now to tan. Let's go to tan. So the double angle says tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B over 1 minus tan A tan B. So this now, so the double now comes to say tan A plus A is equal to tan A plus tan A over 1 minus tan A tan A. Right? So if you look at this one now, we can now simplify. So this becomes tan 2A is equal. What is tan A plus tan A? It becomes 2 tan A over 1. What tan A times tan A is tan squared A. So this is our third identity. So for tan squared A, we only have one identity. For tan 2A, sorry. But for cos 2A, I have identity 1, 2, and 3. And for sine 2A, I have only one identity. So we can these 5 identities are what we call a double angle. They are generated or they are derived from the compound angles because we are saying they are double because they are equal. So we can use this now to solve problems. Let's do some questions. I'll always be bringing back that sheet so that you will be able to see. So let's do an example. It says, so let's do an example. It says, so for theta between 0 less than theta less than 360. Says what? Says so. So we're going to solve the first question, which is it says 2 sine 2 theta is equal to cos theta. So you can see that sine 2 theta is a double angle. So how are we going to solve this one? We're going to use our, we can see for sine 2 theta, we only have one identity. We only have one identity. So I'm going to now, where there's theta, there is A. So I'm going to expand. So it's 2, open the bracket. Do not fall, because sometimes you will confuse these two with this 2 here. So for sine 2 theta, just open the bracket. You later on, are there only 5 double angles? Yes, there are only 5 double angles, right? So now you substitute sine theta cos theta is equals to cos theta, right? Now we must expand now. This becomes 4 sine theta cos theta is equal to cos theta. So with here now, you must be because remember we said when we want to solve, we want to be left with one expression, right? Where I can solve. If I have sine cos, it's difficult for me to solve. But if you look at this one now, if I can choose to divide and say this is cos theta and this is cos theta. So let me just divide by cos theta. Here I'm left with 1. So I will have 4 sine theta is equal to 1. Then I can divide by 4 both sides. So I'll have sine theta is equal to 1 over 4. This is not wrong. This is not wrong at all. However, you will not get full marks. I will show you just now. So we can take our calculator here and we can say shift. So theta is equal to shift sine is shift 1/4. If we say shift 1/4, shift sine 1/4, we get in degrees, we get theta is equal to 14.47, let's say 78. So this is our principal value, right? Yes, divided by cos theta and cos theta. But this is not, I'm not saying it's wrong, but you omit in some important solutions. I will show you just now. I'm just doing this one of dividing, then I will show you the other one here on this side, where another method where you can get all the solutions, because this one will only give you some of the solutions, but not all of the solutions. So this is the principal value. But remember, for sine, we said theta. Remember or as I shared yesterday, I'm going to share it again now. Let me quickly share it. It is here. It is right. I'm just going to quickly check it here. Okay, I'll open it as soon as I have it. Let me stop sharing. I just want to quickly show you the important that you must know. So these ones you must know. I'm going to share them now. There we go. So we said we can get our, for sine, yes, sine. We can get our sine by saying is equal to shift sine theta plus k times 1 times 360. Or we can get by saying 180 minus shift sine theta, right? Whatever, shift sine, whatever we have here, plus k times 360. So I'm going to quickly use this one that we have here. So I'm going to stop sharing now so that we can see that one. So I have written it down. So since my principal value is this one, I can now get my values here. So the first one is 14,478, right, plus k times 360. So let's say it's just 360. So this one will give me 74.478, which is wrong because it is not in the what? Not in the range. Not in the range. So I'm now going to use this formula, which says 180 minus. The first one is 14.478, which is equal to what? So 180 minus 14.478, I get 165.522. So this is within range, and the other one is this one. So in this case, I only get two solutions. I have solution number 1, solution number 2. But if you do it this way, right? If you do it this way, it is you miss out on some of the what? On some of the solutions. So the best way to get all solutions is to factorize. So I will now 4 sine theta cos theta is equal to cos theta. Then I can take it to this side. So it gets 4 sine theta cos theta minus cos theta is equal to 0. Right? Then I can factor out. So I will have cos theta factor of 4 sine theta minus 1 is equal to 0. Therefore, cos theta is equal to 0, or 4 sine theta minus 1 is equal to 0. With this one, it is the one that we solved here. So I have my solutions already, which are 14.478 and 165.522. So I have my two solutions already, and cos theta is equal to 0. Okay, we can also solve it. It says cos theta, so shift cos theta, shift cos 0, it's 90. Shift cos 0 is 90 degrees, so theta is equal to 90 degrees, right? But remember, we also have another one. I'm going to quickly share. We have this one. For cos, it also follows the same principle as this one, right? So for cos, it's theta is equal to shift cos x plus k times 360 degrees. The other one is theta is equal to, we're talking about this one, is equal to 360 minus shift cos x plus k times 360. So the shift cos is the principal value that the calculator gives me, right? So I'm going to quickly dismiss this. Right. I've stopped sharing. Right. So now I can now come and say theta is equals to 90 plus 360. It goes out of range. But I can say 360 using this one minus 90. Then I get 270. So you can now see that if I use this method, I can get 4 solutions, which are the correct solutions. So it means here, if you use this method and where you divide, you lose. So you won't be able to find these 2 solutions. So where you're supposed to get, let's say 5 marks, you only get 3 marks because you did not you did not utilize the other factor to get the other 2 answers. So that's one of the. So let's do another question involving the use of double angles. Right. I am going to write it down. So it says tan 2 theta is equal to 4 tan theta. Okay, since we are on tan right now, we will be able to show how do we find the general solution if we are using tan. Right, so tan 2 theta, we know from our double angle, tan 2 theta will come, yes, tan 2 theta. We say tan 2 theta is equal to 2 tan A is equal to 2 tan A, tan 2A is equal to 2 tan A over 1 minus tan squared A. That is our formula. So now we come and write tan 2 theta is equal to tan 2 tan theta over 1 minus tan squared theta is equals to 4 tan theta. I just replace this with the identity. Now, the next thing to do is to cross multiply because this is over 1. So I'm going to cross multiply. It becomes 2 tan theta is equals to 4 tan theta minus factor of 1 minus tan squared theta. Right? So with this one, right? So now I can expand it. It becomes 2 tan theta is equals to 4 tan theta minus 4 tan to the power 3 theta. You can actually see tan and tan squared. They give me tan to the power 3. Right? So I can take this to this side. I can get 0. I can rearrange this and write it as 4 tan cubed theta, right? If I take it to this side, minus 2 tan theta is equal to 0. Right? Now I factor out what is common. What is common is 2 tan is common. Factor of 2 tan 2 squared minus 1 is equal to 0. So the moment I do this, it is easier. If I had left it on the other side, we would have the same scenario we had last time, where we would lose some of our solutions. But in this case, our solutions are all there. So now we can say 2 tan theta is equal to 0, or 2 tan squared theta minus 1 is equal to 0. So I have 2. With this one, I can shift tan 0, because if I divide here by 2 and by 2, I get tan theta is equal to 0. If I say shift tan 0, I'll get 0. And I'll get 180. If you say theta tan 180, you get 0. And you also get 360. Right? Because why? Let's look at the general solution of tan. We're going to go into the general solution of tan. The general solution of tan. The general solution, I'm going to write it here. The general solution is just theta is equal to shift tan. Let me write it in another color so that we can always make reference. Tan x plus k 180 degrees. So it means whatever principal value that we get, we simply have to add 180 multiplied by an arbitrary constant. Right. So we come back to our, I want to stop sharing. So I think, look, you have been answered. Yes. So here, that's why I said 0, because it's 0 here. 0 plus 180, I get 180. 0 times 2 times 180, I get 360. So you can actually see that from, if I had omitted this, I would have lost 3 solutions. I would have lost 3 solutions. Because we remember our question says from 0 less than theta less than 360 degrees. Right? So now let's go to this one. Right? With this one, I will have 2 tan squared theta is equals to 1. Then, therefore, tan squared theta is equal to half, because I can divide both sides by 2. Right? If I divide both sides by 2, therefore tan theta is equal to plus, because if I square both sides, I get plus or minus the square root of 1 over 2. Sorry, square root of 1 over 2. If I square both sides, so I have tan theta is equal to square root of 1 over 2, or tan theta is equal to minus square root of 1 over 2. All right. So you see, I have 2. I have separate because I have squared. So if you just get this one, if you square and just get this one, you will not exhaust all the important solutions. So you must get all the solutions. So also on this side, which is the negative. So I'm going to deal with this side. So shift tan the square root of 1 over 2 is equal to 35.264. So theta is equal to, but remember, by the general solution, it will simply ask me to add 180. So I'll add 180, I'll get another one. Theta is equal to 215.26. Then here, if I add another 180, I'll get 395, which is out of my range. So I'm only interested in this one. So, or here, shift tan negative. Do not forget the negative. So shift tan, then you put a negative square root of 1 over 2. We get negative 35.26. But so theta is equal. But this is not within range, because why? The range is supposed to be between 0 and 360. So what do? I add 180. So plus 180. I get 100 theta is equal to 144.73. Then I add another 180 because this is within range. I want to check, does it still remain within range? So plus 180 again, I get theta is equal to 2324.73, which is within range because it is between 0 and 360. If I add again another 180, I get 504. No, it is out of range. So do you see how many solutions I got? I got 1, 2, 3, 4, 5, 6, 7. Those are all the solutions that I got that are between 0 and 360. That is if I do manipulate my equation correctly. So I got 7 solutions. So what I'm going to do now is I am going to do another example, because we really need to know how to solve and using your quadrants. Your quadrants are these general solutions. So let's do another one. I'm going to try to look for a more difficult one, right? Then we're just going to do this one is tan. Let me look for something with a cos. So it's 1 plus cos 2 theta is equal to 2 sine squared theta from negative 180 for theta is 180. Right. Can you see that this one, our range has changed? Our range has changed because our range is between negative 180 to 180. So now with this one, we're going to implement two identities because, so remember when I said your objective is to put it in one, to get cos theta is equal to a particular value or constant, and sine theta is equal to a particular value or a constant, right? That is how we will be able to solve. So the objective is to get them to have the same trig ratio. To have the what? The same trig ratio. I know cos 2 theta. So for cos 2 theta, I have 3. I'm going to write them down. 3. So cos, I'm going to write them here. I have cos 2 theta is equal to 2 cos squared theta minus 1. Or it's 1 minus sine squared theta. or it is equal to cos squared theta minus sine squared theta. These are the three. These are the three. So before I continue on that one, someone is asking me how many marks. It depends on the type of question, because if it carries 7 marks like this, it might carry maybe 5 marks or 4 marks just for your steps, or 5 marks. So it depends on how many solutions you are asked to find and on the question, but generally it's 4 to 5 marks. So when we come back here, we have three identities that we can use. So the question is now is, which identity should we use? Which identity should we use? So first, I'm going to show you, I'm going to use the first identity, and I'm also going to use the second identity to see, do I find the same answers? Just to show you, you can use any of the three identities and you still get to the same what? The same answer. So with this one, it becomes, I'm going to use the first one. It becomes 1 plus 2 cos squared theta, right? Cos squared theta. Okay, let me use the one that I can, that is simpler first. So I'm going to first use this one, which is similar, because it is easier just to convert this in a form of sign, then group the signs together, then solve. So it will be 1 plus 1 minus sine squared theta, 2, sorry, is equal to 2 sine squared theta. So this one and this one becomes a 2. And this negative 2 comes this side. It becomes equal to 4 sine squared theta. You see, I've taken this one. So I've just substituted where there's cos 2a, I put 1 minus sine squared a. Then now I expanded and put it this side. So now I can divide by 4 and divide by 4. So I have sine squared theta is equal to 1/2. Now I can write it as sine, so I can square root both sides, remember. So I can have a sine theta is equal to square root of 1/2, or sine theta is equal to negative square root of 1/2. Do not forget the negative part, because you will lose some of your solutions. Right? Now I can come and say shift shift sine square root of 1/2. It must be 45, if I'm not mistaken. 45. So theta is equal to 45 degrees. 45 what? 45 degrees. And I know if this is the principal value, right? If I add 360 to it, it becomes out of range. If I subtract 360 from it, it goes out of range. So I'm only interested in the principal value. That is, even if you draw the graph of a sine, you actually see that it is that's the only value you will get. Then shift sine negative square root of 1/2. We get negative 45. So theta is equal to negative 45. Yes, it's negative, and it's 45, and it is correct, because it is within the range from negative 180 to positive 180. Right? If we add 360 to this, it will not work. If we look at the general solution, let's take the general solution and bring it back. I'm looking for the general solution. Okay, let's quickly share it. If we look at the general solution, for sine, even if I say 180 minus, so with this one, remember, we said the general solution, it can be 180 minus the principal value, which is shift sine negative x plus k times 360. So I can come and say 180 minus 45. 180, so I'll come, it's 180 minus what I get. 180 minus 45. It is 135. So let's look at 135. Is it within the range? Yes. So theta is equals to 135. And if you say a sine 1, it will give you this. And this one, let's check it out as well. It's 180 minus negative 45. (180) minus negative 45 is 225 out of range. So you see, we have 45 and we have 135, right? Or I can say negative 45 plus 180, it still gives me this. But if you look at the graph now, let's draw the graph together. The graph of sine is like this. So if I have these two solutions are simply, let me quickly share the screen again. Okay, I'm just quickly check your the questions I have here. Is divided by 4. Yes. Look, cos 2x is equals to 1. I'm going to share again. Yeah. Cos 2a is equals to 1 minus 2 sine x. So these are the 3 identities we can use. We derived them when we studied our lesson. So I'm gonna go back here. If you're not sure or if you have missed something, you can revisit the lesson again, and you will be able to figure out where you missed something. So with this one, you can see that I can also have theta is also equal to negative 135. Because if you say sine negative 135, you get the same answer, this one. So it's also, was if you cross here, it will also cross 2 points and 2 points here, if you know how to utilize the graphs. Or you can use the general formula, because the general formula is this one, or it is sine plus negative k times 360. So if I have 135, so it's 135 minus, okay, just use, if you can use the graph, it's fine. I do not want to confuse you. So here we substituted with this one. Let's go and substitute with this one. It says 1 plus cos 2 theta is equal to 2 sine squared theta. So I can substitute with the first one, which is 1 plus, open the brackets, cos squared theta minus 1 is equals to 2 sine squared theta. So it's 1 plus 2 cos squared theta minus 1 is equal to 2 sine squared theta. But remember, we have an identity as well, which says that cos squared theta minus sine plus sine squared theta is equal to 1. That's a common identity. So I can now shift and change this one to sine by saying cos 2 theta is equals to 1 minus sine squared theta. So now this becomes 1 minus 1. This one and this one cancels out each other. So I'll have 2 factor of 1 minus sine squared theta is equal to 2 sine squared theta. So 2 minus 2 sine squared theta is equal to 2 sine squared theta. So this will go to this side. It becomes 2 is equal to 4 sine squared theta, which is the same as what we found here. Right? And you can still solve. So do you see that even if I use this identity, I had to implement another identity so that I can get here. So that's why I was referring that you can use these three. Anyhow, which one at the level at which you find it easy, that okay, if I substitute this one, I don't have to introduce another identity. But if you use this one, you have to introduce this identity later on. So you choose by the level of difficulty, right? Which identity must I use? Because if you get back here, then you are able to solve. So I will share the screen again of the questions that you can go and try. I highlighted them yesterday, but these are the questions that you can solve using these ones. Cos y is equal to sine 2y. It's the same thing that we did. Actually, this number B, we did it on what's the name? We did it on our first example. Sine 2 theta is equal to cos 2 theta. Right? You can just write the general solution. Right? If you are asked the general solution. In this case, I can just write that the general solution is 45 plus k times 360 instead of finding the particular solution. So you can attempt this now. Then tomorrow we'll also be doing some more difficult questions with regards to our identities. But I think you now have an overview of how does double angles come about and how are they used interchangeably to solve complex trigonometric equations. But I don't think it should be difficult for you very much. And I thank you for coming in and tuning in. I hope you enjoyed the lesson. Let's meet tomorrow and we can go through some more questions. Then we'll take it up from there. Continue to tune in on our lockdown school. Go to our Twitter handles if you've got any questions. You have seen my Twitter handle and my Facebook handle at the beginning of the page. Feel free to ask online, then I'll come with questions tomorrow. Thank you very much. Have a great day.